Okay, now we're going to finish section 11.2. We looked at prisms, how to find the lateral and surface area in the last part of the video. And now we're going to look at cylinders. They're very similar to the prisms. It's just that this time the bases are always circles. So just like before, we have the bases that are parallel to each other. This time, when I unroll the cylinder like a net, it's going to just be a rectangle that's wrapped around those circles. So I have right cylinders here shown where the height is the lateral edge, and in the leftmost cylinder I've got the bases colored in. Those are always circles. And then to the right I have an oblique cylinder, which is just one that's slanted over a little bit, but which means the height has to be drawn from the outside, that altitude there. So we're going to treat these very much like we did the prisms. I'm going to look at what happens when I unroll these. So here's my cylinder in the middle. On the left, when I unroll the sides, they're connected around the circle. So when I unroll it, the length of that rectangle is going to be the circumference of the base, because that's the distance around the circle. And so in order for, let's think of it in terms of a can, in order for a can to fully be connected, you would have to have the same distance around, that the rectangle, the sides of the can would have to be the same distance around as the base, the top or the bottom of the circle. So that's going to be the circumference, and then the height will be the same as the height of the cylinder. So a circumference we can find by doing 2 pi r or pi d. So I have drawn in a radius on my cylinder, but sometimes they might give you the diameter, and we'll need to either use pi times d to get the circumference or 2 pi r. So in this case, my lateral area will just be the circumference, so 2 pi r times h, or you could use pi times the diameter times the height. So either one of those will work for the lateral area. Now on the right side of my cylinder, I have also drawn in the bases that have a radius of r there. So my surface area will be the lateral area plus 2 times the area of the base, since there are 2 of them. So the lateral area I'm going to write out as 2 pi rh. We know that it could be pi dh, but for now we're just going to write the 2 pi rh. And I'll be adding to that the area of the base times 2. So the area of the base will just be, it's the area of a circle, so that's always pi r squared. So it'll be 2 times pi r squared. So in the case of finding surface area, if you know the diameter, you might as well find the radius first and then just use all radius in your formula. Okay, now let's look at an example. Theorem 11.2 is just restating what those formulas are. So in example 3, the radius of the base of a cylinder is 4 inches and the height is 6 inches. Find the surface area of the cylinder in terms of pi. So remember, the surface area is going to be the lateral area plus 2 times the area of the base. Or we can write it as 2 pi rh plus pi r squared. Oh, I'm sorry, the 2. I got to put my 2 in there. 2 pi r squared. Alright, and I should have everything I need to plug into this formula. So 2 times pi times the radius, which I was told was 4 inches, times the height, which is 6 inches. Alright, that's the lateral area, plus now I'm going to do 2 times the area of the bases. So 2 times pi times the radius squared, 4 squared. That's going to give me 2 times 4 is 8, times 6 is 48 pi. That would be my lateral area, plus 2 times pi times 4 squared, which is 16. So 2 times 16 is 32 pi. Now they asked me to leave this in terms of pi, so I'm just going to add the numbers in front. 48 plus 32 would be 80 pi, and that's, the units would be inches squared. Alright, and let's look at the quick check problem. So this is quick check 3. I want you to find the surface area of a cylinder with height 10 centimeters and radius 10 centimeters in terms of pi. So pause and figure out the surface area for this cylinder. Okay? Hopefully you took time to work that out. I'm going to write down my formula again. 2 pi RH plus 2 pi r squared. Alright, so this time I have the radius is 10 centimeters, the height is also 10 centimeters. I'm just filling that into my formula. I'll have 10 times 10 is 100 times 2 is 200 pi. And then I also have another 10 squared is 100 times 2, so another 200 pi. Those don't always end up the same, but they do this time because the radius and height are the same. Right, when I add those together, I get 400 pi, and they asked me to leave it in terms of pi, so I won't put it in my calculator. And the units that we're using are centimeters this time, so my surface area will be in centimeters squared. Okay, so now go back and try to find the areas of cylinders in your section 11.2.